Welcome to the session on zOS transparent cloud tiering. As you can see by the fact that we have an SMS development architect, a DS8000 development architect, and a TS7700 architect, this is spanning a fair amount of the IBM product line. So I believe that we're going to start with SMS first. What I'm going to do is just hand straight over to the speaker. So rather than me make a complete hash of confusing their bios, I'll let you do it yourself. I'll let you go through your bios rather than make a hash of your bios. So I think it's you first, Robert.
Sure. Thank you, Nigel, and
Okay,
good afternoon, everyone. Do you need to start recording? All right, good afternoon, everyone, and thanks for joining. My name is Robert Gensler, and I am an architect within DFSMS. I'm actually the DSS Dataset Services product owner. And with me, I have Emmanuel Barajas. He's a DS8000 architect, the TCT architect for DS8000. And I also have Lori Goodall, who's the TS7700 development architect. And why is there three of us? Is because transparent cloud tiering really is a solution that combines software on IBM Z and zOS with the DS8000 TCT technology and the TS7700. So you have all three of us today. Next slide. And let's go ahead and move on to the agenda. So I'm going to very quickly give you an overview of what transparent cloud tiering is and the use cases that are good targets for exploitation. And I'll wrap it up with a little bit of what we've done this last year within DFSMS and TCT. I'll hand it over to Emmanuel. He'll give us an update on the DS8000 side and the TCT multi-cloud support. And then I think what we're all really excited to hear about is Lori with our TS7700 update and what we're doing with the advanced object management. Okay, so the strategy within DFSMS when it comes to data management is to minimize the physical data movement through the IBM Z host by leveraging leading edge storage solutions. This isn't a new strategy. This has been something that has been ongoing for at least the last 20 years. I've been around in IBM and DFSMS for about 18. And when I came in, we were working on flash copy, right? And flash copy is that technology that allows us to move data from one disk in the online tier to another disk in the online tier, right? Similar time, we had our TS7700, our virtual tape servers, managing data within a disk cache for fast access, and then data that wasn't accessed within the virtual tape server could be tiered out to a physical tape, right? More recently, we had the easy tier solution that allows you to move data up and down within the storage, within the DS8000, that primary online storage hierarchy. But if you notice, all of these advanced copy techniques, these advanced functions, worked within a storage tier. Flash copy works within the DS8000. Easy tiers works within the DS8000, or what we would call the online tier, right? With virtual tape, they had their own lifecycle management, but it was within the TS7700. We never had anything that combined those tiers, right? And allowed us to move data seamlessly between them. And so transparent cloud tiering is just that, right? It completes the evolution of the serverless data movement through your entire storage hierarchy. TCT allows you to move data from your DS8000 to your 7700 without any of that data movement, without any of that data coming into the IBM Z. Next slide. So when we talk about, what sort of use cases are we talking about here? If we're talking about moving data from disk or the online tier to a virtual tape, a 7700, the offline tier, Really what we're talking about is archive of inactive data or backup of active data, right? We're not talking about applications that are writing, from host memory directly to tape. We're talking about data that first starts its life out on disk on the online tier, and then is either backed up to the offline tier, right? Or isn't referenced and is tiered out to a lower cost storage. So what we have, our first real use case that we delivered is something, if you use HSM for information lifecycle management, right? You could use HSM to migrate an individual data set or migrate an entire storage group from disk to the offline tier using TCT. This is a great use case to start out your journey, right, onto TCT. It allows you to do a proof of concept and do some initial testing to make sure all the capabilities that you need from the solution are there. Building upon that base use case of HSM migration, as far as a command-based migration, is automatic migration. And within DFSMS, right, we have policies that tell us how the data should be managed. Is that management class policy, right? That says for this data set, you should keep so many backups, or if it hasn't been referenced for 10 days, move it from disk to tape, or now TS7700 as an object store, right? So it's that management class policy that we've updated that allows you to specify a cloud or an object store target to move the data to, if it hasn't been referenced within a certain period of days, or now even size-based criteria. So you can combine days unused or days not referenced with size-based transition criteria to migrate a set of data off of disk onto the TS77 object store using TCT. The next use case is using, instead of HSM, right, another product within IBM and DFSMS called DSS, or Dataset Services. I call this a new use case because really I think the TCT multi-cloud support that Emmanuel is going to talk about really opens up the use case for dataset backups. From what we hear, most businesses have the application groups manage their own backups, their own logical dataset dumps of their data. So if you have two application groups, you may want to keep those backups separate. And TCT multi-cloud allows you to do that, right? So you can use DSS, you can use batch JCL. These application groups can use DSS to dump data sets directly to a TS7700 object store. A very compelling use for TCT is full volume dump support. We're going to spend a little bit of time on that on the next couple slides. But really what you can do is use DSS to dump entire CKD volumes to an object store and then also restore them. And finally, as a statement of direction, HSM's fast replication support, the DB2 backup system capability, that's something that we look to deliver in the first half of next year. And that will allow you to dump, with a single command, an entire DB2 subsystem to a TS7700 using TCT. So that's a really exciting solution that we have to look forward to. Next slide. So DSS full volume dump, it expands the possible use cases for backup of active data. Very quickly, it's supported on zOS 2.3 and 2.4 with PTFs, and it is in the base zOS 2.5. Our TCT is a true continuous delivery solution, and so really go out. There's a fixed category. When you start to look at a proof of concept or implement this within your shop, go grab the latest PTFs using that fixed category. Supported on the 8900 with 9.1 microcode release, and the TS7700 with the 8.5 level of microcode. When you switch from backing up your data using, to virtual tape, to backing up your data using TS77 as an object store, we no longer have I would say, the management of that data that we had with virtual tape. So what we've done is provided some commands to help you with that management of those dumps. So when you're looking at HSM, remember HSM migration, it has its own inventory. It manages expiration of those migration copies and all of that. But when you look at DSS, we don't have an inventory. We don't have that management capability, right? That was done for us by something like RMM. That doesn't exist for the objects in the TS7700. So these list and delete commands allow you to create some JCL that you can run along with your backups to manage those backups that you're creating. Also, with the full volume dump support, we have a keyword that allows you to protect your account credentials. So there's really two data paths. We have a small FICON command that we issue to the DS8000 that says move these tracks to the cloud, but there's a lot of administrative commands that we use a RESTful API with, and we use the DS8000's HMC to do that communication. The way we communicate with the DS8000 HMC is to log in. There's a user ID and there's a password. And we need to protect that user ID and password. So we have a ISPF application called Cloud Data Access Authorization Utility. And we have a keyword within DSS that allows us to interact with that CDA application. So we can hand off those credentials securely without them being exposed in the JCL or anywhere else. Slide. Okay. If you haven't seen the 2.5 announce, we published some more recent CPU numbers around full volume dump, up to 98% savings, right? So DSS is a pretty lean and mean data mover. All of the CPU is within reading that data off of disk and writing it to virtual tape, right? And if we can offload all of that, we've offloaded all of the work that DSS normally does. So with full volume dump, you can see amazing CPU savings. And as the size of the volume grows, right, the savings goes up, but it's essentially no CPU. Next slide. Okay, I want to talk just a little bit about a few enhancements, and then I'll turn it over to Emmanuel. Emmanuel's going to talk about the multi-cloud support, but within that APAR, within those PTS for that APAR, we added short VTOC NQ support for DSS full volume dump. So typically when we dump a volume, we're going to have the VTOC reserved for the duration of that dump. We have an installation exit that allows you to tell DSS only reserve the VTOC for the duration of the scan, right? So all of the data movement, the VTOC isn't reserved. We didn't support that initially with TCT, but we got some feedback from clients that said they'd like to see that within our solution. So we've delivered that within those set of PTFs. We have a CDA creds enhancement that we'll talk about, as well as a couple cloud utils enhancements. So CDA, this is this Cloud Data Access Authorization Utility. This is that ISPF application that will help you secure that username and password for the DS8000's HMC. Now, by default, CDA is going to encrypt the username and password with a key label it creates, and it's going to store it within ICSF. And before storing it in ICSF, by default, it wants to wrap the key used to encrypt the credentials with the master key of the Crypto Express adapter. It's a lot of security crypto stuff, right? Essentially what it means is, if you don't have a Crypto Express adapter configured for your processor, well, you can't use CDA. What we did with OA 60481 is we've lifted that restriction. And so the use of CDA and CDA creds no longer requires a Crypto Express adapter. If you don't have one configured, there's a JSON file that you configure, allow no CEX true, right? And if you don't have a Crypto Express configured as a CCA coprocessor, right, CDA will store that key label and that key within ICSF. It just won't wrap it with the master key. Okay, so it's a clear key stored in ICSF. You can take that same configuration, move it over to production where you do have a Crypto Express adapter, no changes, and we'll wrap that key and we'll store it securely within ICSF. Next slide. We added a new all keyword. So when you dump to virtual tape, right, you have a data set on a logical volume. When you create a backup with TCT, it's a set of objects or a set of files linked together by a common prefix, right, within a container. And so when we added this cloud utils list command to let you list objects within a TS7700, we did it at that prefix granularity. We never showed you all of the objects that were associated with a particular prefix. We got some feedback, and you know, you all would like to see a little more detail, right? You want to see the objects that are associated with the prefix. So we added an all keyword, and that will allow you to see, you know, within the example here, right? We have a few backups, and you can see the objects that are associated with those, with that prefix. We'll also show the orphans. Now, if a backup fails, DSS is going to go to great lengths to clean up whatever it's written. But there's cases that orphan objects may get left out there within a container. And before, there was no way you could see those, right? And so with this cloud utils list all, you can now see orphans within a container. Next slide. Okay, and going along with that, if you have orphans in a container, you need a way to clean them up without deleting the entire container. So we have this force keyword on the cloud utils delete command. And that really, the initial definition or usage of that keyword was to allow you to delete a container that still had objects in it. Basically, it was the force option on remove, right? Delete this container even though it's not empty. What we did is we allowed you to specify force with the object prefix now. And what that allows us to do is delete orphaned objects with that prefix that you specify. So now there's two uses of that force keyword within the cloud utils delete command. All right, with that, I will turn it over to Emmanuel for a DS8000 update.
Thank you, Robert.
Thanks.
Can we move to the next slide, please? Thank you, Lori. So good morning, good evening, everyone, and thank you for joining during this next part of the presentation. I'm going to be talking about TCT from the point of view of DS8000. And the first thing I'm going to do is to do a quick recap on what Transparent Cloud Tiering for DS8000 released in 2020. So in 2020, one of the main features that we included was to fully support the TS7700 as one valid object store target. Before that, we only supported traditional clouds to be configured for TCT, but in 2020, we added support for the 7700. Along with that release, we included a couple of enhancements in the way DS8000 connects and transmits data to the 7700 in order to optimize it. One of those optimizations was to introduce TCT compression with the DS7700 as object store. So what we do, or what DS8000 does, is to really compress the data before it's transmitted over the network to the 7700. So that by the time it arrives to the 7700 and it's stored in the cache, the data is already compressed. The compression is performed by a hardware accelerator that is present in the power CPU of the DS8000. So we don't really take CPU cycles from the main CPU. Again, all the compression is done through a hardware accelerator, and it's compressed right before it's sent over the network. So that also implies that the amount of bandwidth that is consumed by these transmissions of data is less than if it was not compressed. Another optimization that we included with this release was to support secure data transfer, or SDT, with the 7700. So in the 7700 world, whenever you have multiple clusters configured in a grid, those clusters can communicate securely by using encryption in the Ethernet communications. So what we did with DS8000 is to use the same mechanism so that whenever the DS8000 is connecting to a 7700 grid, it is also going to be able to do encrypted communications by using the secure data transfer mechanism. One important thing to mention is that this encryption is also performed by a hardware accelerator that is present in the Power9 CPUs of the DS8000. And similar to the compression algorithm, we are not really taking cycles from the main CPU. Everything is hardware accelerated. Can we move on to the next slide, please? Okay, so now what's next? We are introducing support for multiple clouds, multi-cloud support. So before, we only supported the definition and the configuration of a single object store target, whether it was a traditional cloud or a 7700 cloud. You were able to configure and use only one cloud at a time. If you wanted to switch to another type of cloud, what you really needed to do is to go and remove the prior definition of your cloud, and then create a new definition with the credentials and the connection information to reach the new target. We are now introducing multi-cloud support, and with multi-cloud support for the DS8900, we now allow you to configure up to 8 cloud targets. So those 8 cloud targets can be either public cloud, off-premises, object store, private clouds, on-premises, object store, and even DS7700 as object store. And not only that, but we allow any combination of public, private, and 7700 targets configured at the same time. And additional to that, we are allowing not only a single DS7700 grid to be defined, but we can support multiple 7700 grids configured at the same time. So you have 8 slots, and you can use those 8 slots in any way you want. You can use them all for 7700s, or you can make any type of combinations between 7700s and public or private clouds. When using TCT to move data out of the out of the DS8000 or into the DS8000 with TCT, we allow you to run multiple and concurrent jobs simultaneously. That means that you can be running migrations to your private cloud, and at the same time, you're restoring data from a 7700. So the DS8000 and each one of the nodes in the DS8000 has predefined slots or work slots in which you can always make sure that there is going to be resources reserved for each type of cloud, depending on the job that you are running. But those jobs can be running at the same time, regardless of the type of cloud. Now, I mentioned before that in the past, we only supported the definition of one cloud target, and that also extended to the definition of the cloud on the zOS configuration. We are now, with the introduction of multi-cloud support, we are now also supporting the definition of multiple cloud targets in the SMS definitions by applying the APARs required in order to do that. So multi-cloud support, it's now extended not only inside the DS8000, but also to the configuration of the mainframe host, so that it also can allow you to define multiple cloud targets that are going to be using TCT to move data. This enhancement was introduced with the DS8900 microcode version 9.2, which was released in August of 2021 of this year. Now with multi-cloud, we can talk about and consider multiple and new use cases for TCT. So one of those use cases, as I said before, you can have multiple DS7700 grids configured at the same time. So you can now really separate your production from your test environment workloads based on cloud names. Even if you are using or you are targeting the same 7700 through different cloud names, which is allowed, you can do that, or you can target different 7700 grids in order to separate different types of workloads. You can separate private and public clouds in order to keep your security or to maintain security levels of data. So you can keep confidential data on site going through your private cloud, while other type of data can be moved to public clouds. And all of that can happen at the same time. You can separate your clouds by performance so that you can keep the more active and most frequently used clouds to be used probably on 7700. But other type of data that is less referenced or colder data can be stored on public clouds. You can even separate by application. So now you can probably have one cloud that is defined to be used for HSM and DSS workloads, and other type of clouds, you can separate them by defining different user IDs and passwords into different cloud targets. Even at the public cloud level, you can now separate by service provider. So probably you have some accounts to a public cloud provider and on another type of cloud with another type of tiering that is used for less frequently used data in the same provider or with another provider, but all of them are public. So now you can define and you can separate your workloads based on the provider where the data is going to be stored once you move it to the cloud. Now, moving on with the new thing that is coming on in the near future. We are introducing the DS8000 TCT support for TS7700 Advanced Object Store. All of the use cases I just mentioned with multi-cloud when referring to TS7700 were using what we call the legacy of the traditional API to communicate with the 7700. So in order to give redundancy to the data, what we were doing at the beginning was to make sure that if two 7700 clusters were defined under the same cloud name, then every single time you wrote an object to the 7700, that object was going to be basically forked into two objects to keep redundancy. So at that time, we didn't have full integration with the 7700 grid. So other than being able to write the object into two different 7700 clusters, there was no way for us to give more or more advanced capabilities for the management of the objects. With the introduction of the 7700 Advanced Object Store, DS8000 is no longer doing forked writes to the 7700 clusters, but instead, thanks to the integration with the 7700 grid, the workload is now balanced across the grid. So it's not only targeting a couple of 7700 clusters, but now it's it can be balanced across the whole grid that is defined. The DS8000 continues implementing retry mechanisms inside the DS8000 itself. So if, for example, one of the nodes of the DS8000 detects that there is an error, this retry mechanism is going to automatically repeat the operation from the other node in order to try and succeed. In order to optimize the way we are connecting with the 7700, the DS8000 is now keeping a pool of connections. So we are not opening new connections every time we are moving data from or to the DS8000. We now keep and maintain this pool of connections that is reused and recycled based on the needs of the workload. Finally, we have a link health monitor in each one of the DS8000 nodes that is able to post events into the DS8000 GUI whenever there is a change in the state of the connectivity with the 7700s. And with that, I give it to you, Lori.
Right. Thanks, Emmanuel. So now we're going to get down to the 7700 specific items. And I'm going to take a step back and just talk about what we already released in the field in 2019 as part of our release 5.0. We first introduced 7700 as an object store for this DS8000 TCT. And this was a wonderful solution because it didn't require the user, the customers, to go out and purchase any additional hardware. You didn't have to go out there and buy an external cloud system. Instead, you use your TS7700 that was already on the floor that housed your tape, virtual tape volumes, and now this 7700 could do both. So coexistence of virtual tape and object data in the same 7700 using the hardware that we already had. So using the same cache system, no separate cache needed. In fact, we utilize our cache partition technology that we've had in our system for years, and we just kind of separate that tape versus object data out. That continues to go on. And as Emmanuel just explained as well, at the time of this release, DS8000 would do the synchronous copies to two 7700s in the same grid so that you had redundant copies. And you no longer have to do that with our new offering that we'll talk about in a minute. Back in even 5.0, one of the things that we didn't mention was that you can have multiple DS8000s targeting the same 7700s. So it's not just one DS8000 that can target a 7700 or 7700 grid. We could have, we supported up to 256. And this grid, the 7700, if you're familiar with 7700, can be a standalone, could be a two-way, all the way up to 8-way. Although DS8000 can only actually communicate to two of those clusters, but there's no limitation on the size of your grid. And that feature was called 5282. It's been out in the field for a couple of years now. So one of the things we also introduced was this concept, and I mentioned it already with the cache partitioning pieces. So in the 7700, if you had a disk-only system, there was really only one cache partition, and we called it resident only partition because it just stayed in cache. And if you were only a disk only customer, you probably didn't even know or care anything about partitions because it was sort of hidden in the background, and you didn't really need to know about it because partitioning really was used for tiering data out of the 7700. So if you had tape or cloud attached behind a 7700, that's when you would have to manage data by cache partitioning, and you would have a nice cache partition page that you can access. And now what we've done is just expanded on that and added the ability to have an object partition, and this would separate that DS8000 TCT data from your logical volume data, regardless of whether you had cloud or tape or not. And we've been talking about this for the last year and a half, 2 years since we've introduced this. But one of the things we haven't really mentioned much is the 7700 also separates that data that's in that cache partition, that object cache partition. And this is unique to objects only. But we separate that out, and here I call it cloud name. And what these cloud names are that DFSMS cloud network construct that you have to set up to use TCT from the host. So this is the name you provided in that ISMF panel on zOS to set up TCT going to a certain DS8000. So what we do is we leverage that information and we actually separate the data further out inside the 7700 into these smaller buckets. Even though they're all in the same partition, they are actually logically separated internally. And we did this so that we could provide statistical information by these constructs in the future. And this kind of ties into multi-cloud that Emmanuel just spoke about. So now, prior to multi-cloud, these cloud name buckets, as I'm showing here, I have cloud name 1, 2, and 3 as an example. And each one of those in this time period was indicative of a DS8000 connection, because at the time, DS8000 only supported one cloud configuration. Now with multi-cloud, each one of those buckets could be even the same DS8000, just a different cloud configuration or cloud name. So now it could be from a different DS8000, or it could be from the same DS8000, but the whole thing here is that the 7700 does separate those out, and we can provide statistical information about your object data based on how you set it up. And this actually ties now more into advanced object store that we're going to be talking about, because now there's another purpose for separating it out. So this is release, we call it 5.2.2 or release 5.2 phase 2. We have different names because we did actually deliver a phase 1 earlier this year that had some different content. The feature is called Advanced Object Store, and this is now where the 7700 takes control of the objects within the grid, instead of having DS8000 regulate where that data goes, how many copies that you'll have, and forking it. Now the 7700 takes over that. So as Emmanuel began the discussion, that DS8000, so let's say, for instance, in this image, we have DS8001, and it's got the red lines going to two 7700s. In this image here, this is indicative of a 4-way grid of 7700s. We have 4 clusters in that grid. And that DS8001 is connected to cluster A and B. And in this release, we start load balancing now. When DS8000 connects to those two 7700s, they will be load balancing and not fork writing the same object. So now we have that better performance, that you could be utilizing both clusters in your grid to do work for you. And this is very much how we run the zOS virtual tape logical volumes, where the host can connect to multiple 7700s, load balance between them, and then have the 7700 drive any copies that you have. So 7700 it has now a new policy management for objects. And you can think of it as very similar to your management class today, but we're not going to use management class. We're going to have a totally separate set of policies for objects alone. And so object policy, again, working very similar to management class. You can state, what kind of copies you want to do. Do you want synchronous? Do you want asynchronous? Where do you want those copies to go? Do you need a copy on your local site and then one on your DR site, or do you need 4 copies? 2 locally and 2 on your DR site. However you want to configure it. Again, working very similar how we do with tape logical volumes. So a zOS is all set up, and now you need to go make a copy or write a piece of data that'll go out to backend storage. And DS8000, again, we'll use DS8001 here as an example, goes out and writes the red object to cluster B. And cluster B says, oh, I'm going to replicate this data based on my policy. It's going to C and D, so it does that right. Now, if you need to, let's say cluster B needs to come down for maintenance, that red object can still be accessible to DS8001, even if through cluster A, even if it doesn't have a copy. So in this case, if cluster B is offline and host says I need to recall the red object, DS8001 through A can pull that copy over, do a remote read of that copy actually from C or D, whichever is the fastest that it can do. And then just like our 7700 does very well is that once that cluster B now comes back up and is fully online, it self-discovers or self-heals. It understands that anything that was written while it was down is now it updates its database system and it's fully up and running. So if the yellow object was created while it was down, then it will be told about the yellow object when it comes back online. So again, this is very much how the grid operates with logical volumes, and we are basically doing the same thing because it works. The other thing we do too is that we are working with consistency groups. So instead of processing objects one piece at a time, like we did in previous releases where we have open up one connection, write an object, close that connection, we actually process things in both now. And so DS8000 and 7700 team have worked really closely together on this. Up in the DS8000, they'll open up a connection with the 7700 and leave that connection open. Let's say you have a batch job coming through and you need to do a bunch of puts. Let's say it's a full volume dump. We'll do open up a connection and just go put, up to a certain number before we close that out and then send the information to all clusters in the grid. So there's some additional stuff that we've added as far as efficiencies so that we're now that we have to handle many more objects versus virtual tapes, then we have to be a little bit smarter about how we process. So each cluster in the grid that has this DS8000 feature enabled will know about every object in that grid. So just some additional things to add to it. So once again, we continue to allow this FICON virtual volume data and this DS8000 object workload to coexist in the same 7700. This provides excellent price points because this way, you don't need any extra hardware to do this, any large hardware. Actually, there is actually a small hardware piece that we need to add to your power server to house the new objects, but you don't need a separate cache system or anything like that. We continue again to use the logical cache partitioning like we did before. We still only support one object partition. Secure data transfer for objects is another thing that we'll begin to support. And if you remember on 7700, we introduced feature code 5281 back in 5.0 for tape logical volumes. And this was to provide encryption of those logical volumes when traveling between two clusters in the grid for replication or for copy purposes. We are going to be leveraging that same feature code when we go do a replication of these objects. So if you already have feature code 5281 on your system and are using it for logical volume, it will just work for objects as well. And then more than one DS8000 can target the 7700 clusters. That remains and continues. And then now the new thing is the same DS8000 can target multiple grids or even the same grid. Now, why would you want to have the DS8000 target the same grid for different cloud configurations? And this ties into policy management. And actually, I have another session that goes deeper into this subject about that policy management. So I'm not going to get into this release because there's a lot of information in that area. But we are going to be leveraging those cloud construct names that you set up in zOS as a way for you to decide how you want to replicate. So if you have data that requires synchronous copies, very important to have those two copies immediately, then you could use one of those cloud names, and then we set up internally for you to set up a policy for that cloud name. And so when we see that cloud name, and zOS will send that cloud name through the DS8000 to the 7700, just like, think of it like logical volume policies, construct policies, where on each logical volume, you can tag on a data class and a management class and so on and so forth. Similar concept to that, where this 7700 will get that cloud name, and when you receive that cloud name, you have stated that you want synchronous copies to happen and to which clusters, and that's what we'll do. If you have another set of data that needs to just have deferred copies, you can use a different cloud name. So that's one of the features that we've added that ties into this multi-cloud. And once again, we have a maximum of 256 object store connections that are allowed to the TS7700. So that could be 256 individual DS8000s or a mixture of, DS8000s with multi-cloud on there, but only up to 256. I don't think we'll ever reach that, but you never know. So real quick, just some requirements. 7770 VEDs are required for hardware on the 7700 side, and with the new microcode level, which will be an 8.52.200. some level. We're currently working on this right now. On the 7770, there's actually a separate feature code 8083, and this is what I was kind of alluding to. So my statement about no additional hardware, actually I need to remove that, because this is actually a piece of hardware that is required for this. And what this feature code does is it adds 2 new SSD drives to your Power 9 server. There's 2 vacant slots in there right now that we will install SSDs. And this is where we're going to house your object database. And this is what the driving piece or the heart of grid understanding, where the objects are. So this provides a real fast way for us to store potentially hundreds of millions of object metadata that we would have to know to keep track of all your objects. The main feature for advanced object store is 5283. So this is the new feature that will allow this grid awareness and grid replication piece. So that will be a required piece. And then on the DS8900, this continues to be part of their Z Synergy bundle, but you'll have to have their new code level, which supports us, and that'll be a 9.2.x microcode level to be determined. They continue to support all of their environments, Simplex all the way to Metro Global Mirror and Hyperswap environments. So no limitations on that. On the zOS side, Robert actually just talked about some APARs that you would want to have mainly for the multi-cloud. There's no direct APARs related to advanced object store necessarily, but you'll want the objects, the APARs that support the additional items, including the multi-cloud. And once again, the 7700 could be a standalone or up to 8-way grid. We do support the advanced object store on your 7770 disk only, your tape. Also in cloud, but the cloud does require a RPQ approval, mainly because when we deliver this, we think that we're probably not going to have the cloud attached fully tested yet. That's really the only reason on that. And I should state as well is that even though your 7700 could be tape or cloud, we still don't support objects going to tape or cloud yet. So it's something that we're still working on. But it can be resident only data on those systems. Older 7700 models can exist in the same grid, but they just can't take advantage of the DS8000 TCP target because you have to be a 7770 to handle that. But if you have older 7700s you're still using, they can be in that same grid. And then those customers that now have feature code 5282, the one we delivered in the 5.0, we must migrate you to 5283 before you can take advantage of 5283, and this will be introduced next year in the first half of 2022. Okay, so for this presentation, that's all I have. I have a session next Tuesday. It's 7 AW, And this is where I'm going to get into this feature in much more in depth. So we're going to talk a lot about how this policy will work, what the panels look like, and really to just go deep dive, talk about some of the knobs that you would need to know about and how you get reports and statistical data that we have. So if you're interested and want way more information, attend this session. So we have, I think about 10 minutes about 7 minutes, and I want to open it up for questions.
Yeah, we're now ready to take questions. If you want to ask a question, then you can unmute yourself or you can drop it in the chat window. I don't see any questions in the chat window so far, so let's see, does anybody have anything to ask? So that's sounding like a no. So we don't appear to have any questions. Okay, so please remember to complete the session feedback. I've dropped a link in the chat window, so you can just click on that. So if there are no questions, then it only remains to thank the speakers very much for a very thorough covering of transparent cloud tiering. I would encourage you to come to the third session. This was sort of this session was sort of 2 in a sequence of 3. As Laurie said, next Thursday, I think it said.
Next Tuesday, yeah.
Tuesday, sorry.
Yeah.
I'm glad you're keeping me honest. With that, thank you very much for attending, and thank you very much to the speakers. I'll now drop everybody out of the session. Thanks again.
Thank you.